this video, we shall discuss about further pure paper 2023, May, June, paper 23. Let's take a look at question number 1. The roots of the equations z cube equals to the, find the roots of the equations z cube equal to the 7 3 minus 7i, giving your answer in the form of re power I theta. So where the r greater than 0 and the theta is between negative pi to pi. So what we need to do over here is we factorize the 14 out, make this becomes a 3 over 2 minus half I. Then we direct change it to the polar form first. So I will know that, you know that this one is the positive value. This is the negative value. Negative 7i. So that means from the Argand diagram, you can see that you are at the fourth quadrant. You are at the fourth quadrant. So you can see that this angle is actually negative 30 degree. Negative 30 degree. So you will be having 14 cos negative pi over 6 plus I sine negative pi over 6. So you convert this into the exponential form. Okay, but before I convert the exponential form, I bring the cube root, go to the other side, make it like this first. Then apply the general formula. You can get zk 14 power 1 over 3 cos negative pi over 6 plus 2k pi over 3 plus I sine negative pi over 6 plus 2k pi over 3, where your k is 0, 1, and then 2. So substitute 0 inside, you will get 14 power 1 over 3 e power negative pi over 18i. Then your z1 will be 14 power 1 over 3 e to the power of 11 pi over 18i. Then lastly, the z2, it will be equal to the 14 power 1 over 3 e power 23 pi over 18i. So this will be the answer, 3 of them. That will be the answer for the number 1. Done. So now we move on to the part 2. Coefficients of x squared in the Maclaurin series for the negative ln cos x. So firstly, we let fx equal to negative ln cos x. Differentiate for the first time, you get negative sine x over cos. Then you get positive tangent x. Differentiate for the second time, you get secant square x. Replace the 0 inside, you get negative ln 1. Negative ln 1 is a 0. Replace the 0 inside here, you get a 0. And if you replace a 0 inside here, you get a 1. Okay, so since we only want until x squared, we just need to differentiate until second order of a derivative. Okay, so therefore, your fx equal to the f0 plus the f prime 0x plus the f double prime 0 x squared over 2 factorial plus a dot dot dot. So just replace it inside. You can get my apologies. We're looking for coefficients only. So there's no need for me to do like that. So therefore the coefficients of the x square is actually equals to the f double prime 0 2 factorial. It will be a half. Okay. So we just need to do like this. Okay. That's all. That is the number 2a. Then we move on to the number 2b. Find the length of the arc of the curve with the equations y equal to ln cos x from the point where x equal to 0 to the point x equal to pi over 4. So this one is the length of arc. Length of arc, we know the formula, it should be s equal to integrate from 0 to pi over 4 square root of the 1 plus the dy dx square dx. Okay, this is the formula that for us to find the arc length of a curve. However, we were not going to do this one first. We will find the dy dx first. So we just let this become 1 plus the dy dx square. From the part A, we know that the dy dx is a tangent x. So we have a tangent square x. So tangent square x, we know is a secant square x. Secant square x, if you square it, you get secant x. Okay, so now we are ready. The arc length formula will be 0 to pi over 4 square root of 1 plus the dy dx square dx. That will be the same as integrate secant x dx. So to integrate secant x dx, you can just get it from the formula booklet MF19. Just go for the formula booklet MF19. Search for the formula. You can see that your answer, I will write the answer as a ln modulus of secant x plus tangent x. Substitute 0 and pi over 4. So if I put pi over 4 inside here, I get secant pi over 4 plus tangent pi over 4 minus the ln of secant 0 plus the tangent 0. Okay, secant pi over 4 is actually sub2. Tangent pi over 4 is a 1. This is a 1 plus 0. 1 plus 0. So ln 1 plus 0 is a 0. Okay, so your answer, it will be ln of 1 plus 2. Okay, therefore, that is the answer. Done. That is the answer for number 2b. Move on. We have question number 3. Question number 3. We have a matrix given here. They want us to find the eigenvalue of the matrix A. So what we need to do is just to substitute them. 6 minus lambda. Make it become 6 minus lambda and negative 8 minus lambda and the 2 minus lambda. Then the rest just copy down only. Equal to 0. So 6 minus lambda, negative 8 minus lambda, 2 minus lambda, plus 5, plus 9 of 10 minus 5 lambda minus 5, plus the 5 of negative 5, plus 8, plus lambda, equal to 0. So we just keep expanding. You get 6 minus lambda. This one will give you lambda square plus 6 lambda minus 11. This one will give you 45 minus a 45 lambda plus 15 plus 5 lambda equal to 0. Keep expanding. You will having 6 lambda square plus 36 lambda minus a 66 minus a lambda cube minus a 6 lambda square plus a 11 lambda plus a 60 minus a 40 lambda equal to 0. Then you will get lambda cubed. This can cancel. Okay, then positive. This one you can combine together, 11 lambda, negative 40, and positive 36. So if you join them together, you get negative 7 lambda plus 6 equal to 0. So we can factorize the root out. You can see that lambda equal to 1 is a root. So you factorize it out. Then you get this. Factorize it further. For the quadratic expressions, you get plus 3 minus 2. So therefore, your eigenvalue lambda is equal to the 1, 2, and negative 3. 1, 2, and negative 3. Okay, done for the part A. Moving on, part B, they want you to use the characteristic equations A to show this result, where P and Q are constant to be determined. So the characteristic equations we can copy from here. This is the characteristic equations. We just copy this result to the part B. So from here we get lambda cubed minus a 7 lambda plus 6 equal to 0. Apply Cayley-Hamilton theorem. By applying Cayley-Hamilton theorem, you get a cubed minus a 7a plus 6i is equal to 0. Okay, then you get 6i is equal to the negative a cubed plus the 7a. In order to get a inverse, you multiply a inverse. 6a inverse is equal to the negative a square plus the 7i. 7i. Then after that, you get a inverse is equal to negative 1 over 6a square plus the 7 over 6i. Done. So this will be the answer for number 3B. And moving on, we have question number 4. It is given that we have the parametric equations over here, and they want you to show that the dy dx equal to the negative of t squared plus 1 plus the square root of t squared plus 1 over t squared. There's a negative here. So what we need to do is differentiate the parametric equations. Dx dt, you get negative 1 plus 1 over 1 plus 1 plus t squared. This is a y typing error. Your dy dt is the 1 plus the differentiate upside. Okay, differentiate upside is 1 over square root of 1 plus t squared. Okay, so your we can combine them together first. Negative 1 minus t squared plus 1 over the 1 plus t squared. So your dx dt can be written as negative t squared over the 1 plus t squared. Okay. Then this one you also can combine together, becomes square root of 1 plus t squared plus 1. So your dy dx is actually dy dt divided by dx dt. So that will give you square root of 1 plus t squared plus 1 divided by square root of 1 plus t squared. The whole thing here multiply by dt dx. That means it's a negative of 1 plus t squared over the t squared. Okay. So this portion and this portion can be simplified. Then you will get this as a 1 plus square root of 1 plus t squared divided by t squared. These two, if you simplify them, you will get square root of 1 plus t squared. Okay, now square root of 1 plus t squared, you multiply them inside. Then you will get this as the 1 plus t squared plus the square root of 1 plus d square over the d square shown y dx. Okay, so this is the answer. There's a negative missing here. There's a negative missing here. Because there's a negative here, I miss out. So you can write it like this. Shown. This is the answer for part A. Okay, so now we move on to the part B. Part B, we want to find the value of a d square, a y dx square. So to differentiate this, we need to differentiate from the dy dx. I copy down the result of dy dx over here. So to differentiate this again with respect to x, now I split them to become 1 over d square plus the d square over d square plus the square root of 1 plus d square over the d square. I split them like this, easier. And it will be easier also if I make this become 1. Okay, then we no need to deal with so many d. Okay, so this will make our job easier. Now, to find the d square y ds square is actually d dt, dy dx, and dt dx. Okay, so this one by applying the chain rule. So you just need to copy this result down here. Then you get negative 1 minus d square minus a 1 minus the square root of 1 plus d square over d square. Multiply by the negative dt dx. Just now the dt dx over here is coming from this part. Okay, so we just copy down negative 1 plus d square over the d square. So the negative over here, actually we can simplify it. That will make our job easier. Okay, this will make our job easier. So we can cancel the negative. Then over here, you differentiate this, you get negative 2 over t cubed. This one differentiate, you get 0. Then this one differentiate by apply quotient rule, keep the bottom, differentiate the top. Then minus, keep the top, differentiate the bottom. Divided by the bottom square. This one still remain as 1 plus d square over the d square. Simplify further. This one can cancel. We factorize the d, 1 plus d square power negative half out. Then inside here will remain as the d square minus the 2 minus 2d square divided by d to the power of 4. This is a 1 plus d square over d square. This one can cancel it, become d cubed. So you will get negative 2 d cubed plus we have a minus 2 plus d square over the d cubed square root of 1 plus d square, and the whole thing multiplied by 1 plus d square over d square. Okay, so it's kind of complicated over here, but however, we do not need to simplify further anymore because the questions are not require us to simplify them. The question only want to find the value when we substitute d equal to 3 over 4. So over here, we can stop at here. Square y ds square. when the d is equal to 3 over 4, then your d square y ds square is equal to the negative 2, 3 over 4 cubed minus the 2 plus the 3 over 4 square over the 3 over 4 cubed square root over 1 plus 3 over 4 square multiply 1 plus 3 over 4 square over the 3 over 4 square. So this one, you just need to multiply the things carefully. Okay, just need to multiply it carefully. Okay, just multiply it carefully, then you can get the answer. So this one, I will leave it to you to multiply yourself. My final answer over here will be negative 80 over 3. Okay, negative 80 over 3. Okay, so this will be the answer. Now we move on to question number 5. The differential equations over here, we need to solve this first order differential equations given that when x equal to 1, y equal to 7, and we need to leave our answer in y in terms of fx. Okay, so what you need to do is that we need to know that this one is a linear equations. So first of all, we need to make this become a 1 by dividing everyone by x plus 7. Then I get this. x plus 7. Okay, so this is what we need to do at first. Then after that, sorry, this is a x over the x plus 7. This can cancel. So after you cancel it, we straight away write this one as 1 over x plus 7. Okay. Now, to find the IF, we need to take this one out. We need to integrate them. And to integrate them, we need to do partial fractions. So this one, we just take it out over here. Just spend some time over here to do the partial fractions. So 7 is equal to the ax plus 7 plus bx. When x equal to 0, a is equals to 1. When x is equal to negative 7, so the b is a negative 1. So from here, we know that the IF integrate 7 over x plus 7 dx is actually same as integrate a over x minus the 1 over x plus 7. Then you get e power ln x minus the ln of x plus 7. Combine them together. Then we know that this simplify them by using the law of indices. You will get this. That is your IF. Okay, this is your IF. And we will take these equations over here, multiply everyone by IF. So I call this one equations number 1. Take the equation number 1, multiply the IF. Then I get x plus 7 dy dx plus if you multiply this with x over x plus 7, then you get 7 over x plus 7 square y. That is equals to the x over x plus 7 square. So your left hand side is actually similar to this. IF multiplied by the y. Then your right hand side is this. So my right hand side, I also need to use the partial fractions. Decompose the partial fractions over here. I still need some space over here to highlight or to show how to get the partial fractions. Maybe I don't use A and B, I use C and D. So I get this. C x plus 7 plus D. So x equal to 0, your x equal to 0, x equal to negative 7. So your D is a negative 7. So x equal to 0. So your 0 equal to the 7c minus 7, your c is a 1. Okay, so from here, we can actually split these two to become 1 over x plus 7 minus a 7 over x plus 7 square. Okay, then this one we need to integrate, bringing this whole thing go to the other side, the dx. Then I want to integrate both sides. Integrate the left hand side, I get this. Right hand side, I get this. This one is a plus a constant. But they give you some initial value. So initial value, I need some space over here, not enough space. So the initial value, after you come to here, we need to find the C. Then the initial value given over here is x equal to 1, y equal to 7. Okay, so given when x is a 1, y is a 7. So you just replace them inside here. X is a 1, y is a 7. You get 1 over 8. 7 is equal to the ln 8 plus the 7 over 8 plus c. Cancel this. Your c is a ln 8. So that means replace the c as a ln 8 inside the equations. Then you get this. C is a ln 8. Oh, negative ln 8. Negative ln 8. Okay, then your y will be x plus 7 over x multiplied by ln x plus 7. This one is a 1 minus the ln 8 of x plus 7 over 7. Okay, so however, these two can combine together. You can see that this is a ln, this is a ln, and they share together. We can combine them together. This is not 7. This one, if you multiply together, this part, if you multiply, you get 7 over x. Okay, you get 7 over x. So this one is a 7 over x minus this. So you will get this one as a x plus 7x ln x plus 7 over 8 plus the 7 over x. Okay. So these two combine together, and then you get this. So therefore, that is your final answer. Okay, so done. Now we're moving on. We have question number 6. Question number 6. Okay, we have a diagrams over here, shows a curve with the equations y equal to ln x, where your x is from 0 to 1. And we have n rectangles, each with a width of 1 over n. So by considering the sum of the areas of this rectangle, show that these integrations of ln 1 plus x, that means the area under the curve over here from 0 to 1 is less than un, where the un look like this. Okay, so what I need to do now is, first of all, I will call this one fx. So first of all, I let this call fx. So in order for the area under the graph is less than the un, that means the integrations over here, the area of the rectangle is supposed to be higher than the graph. So to get higher than the graph, this will be my first value, f1 over n. That will be my second value, f2 over n, until the last value over here is fn over n. Okay, so we shall write like this: f1 over n multiplied by 1 over n plus f2 over n multiply 1 over n plus until fn over n multiply 1 over n. Factorize the 1 over n out. You can write the series as this, fr over n. Fr over n is actually ln 1 plus r over n. Ln 1 plus r over n, we can combine the 1 plus r over n as a 1 fractions. Then it will become n plus r over n. That will be easier for us. And we would like to apply the law of logarithms over here. Break them become ln n plus r minus the ln n. Now we want to split these two, become two different series. This first series look like this, which is the sum of a ln n plus r. And the second series will be the sum of the ln n. So you need to aware or take note that this is a constant. Ln n is a constant. So when you sum of the constant, where the r start from 1 until n, then this result will give you n ln n. Okay, so this is something you need to take note. So what we are doing now is that the first series over here, I will expand it out, list it out. I get ln n plus 1 plus ln n plus 2. Keep on adding, keep on increasing the value of r until the r reach to the n. So it will be n plus n, there will be 2n. This one I write n ln n. So this is over here. Okay, and the series over here, I go and expand them out like this. And take note that the log x plus log y, ln x plus ln y is a ln x times y. So when you have the ln all add together over here, we can actually write them in such a way: ln n plus 1, n plus 2 until 2n minus the n ln n. But it's a bit troublesome to leave the answer like this. So we do not want it to make it like that. We want to make it become the factorial. So the n plus 1, n plus 2 multiply until 2n. So the trick is that we multiply n factorial over here, we divide n factorial over here, then this one will become 2n factorial over n factorial. Okay, so over here we just need to apply this trick. then we can get this one as the 2n factorial divided by n factorial minus the n over n ln n. I expand the 1 over n inside here. Okay. So after I expand them, then I get this one as a 1 over n ln 2n factorial over n factorial minus the ln n. Shown. Okay, that is your un. Now we move on to the part B. Similar method. Use a similar method. Now I want to find ln, the lower bound. So to find the lower bound, you can refer back to the graph. This time, your area over here must be greater than the lower height of the triangle rectangle here. You will be starting from f0 over n, f1 over n, plus until fn minus 1 over n multiply 1 over n. Factorize this one out. We can do it faster because after we have gone through the part A, we can do it faster. So over here, it will be, we can straight away write like this result. Okay, just repeat this process. We are repeating this process, so we straight away get this result. No need to repeat the whole thing anymore. Okay. So over here, we will get this. But this is a bit special because you can see that when you put r equal to 0 over here, you get ln n over n. Ln n over n is a ln 1, and ln 1 is a 0. So over here, we want to make our job easier. And in order to apply formula, our r need to start from 1. So we will make it like this. You put r equal to 1 here, you get ln n over n. Now, this time, your r will start from 1 over here. So this is a 0 plus the, I no need to write 0. 0 is understood already, so I no need to write it out. So this one r equal to 1. This one is a ln n plus r minus a ln n. Okay. Then you just need to apply the same concept. This will be a ln n plus 1 plus ln n plus 2 plus until ln 2n minus 1 minus the n minus 1 ln n. Similar to part A, but because the series over here is we only have n minus 1 term. Okay, so you can only have n minus 1 here. You can only have 2n minus 1 over here. Okay, so have to be aware of the situations over here. It changed already. So now, same thing, same trick over here. This is this. Okay, and this part is this. Okay, so same trick. We will get this one as the sum of ln 2n minus 1 factorial over n factorial. Since it's the same trick, we will not going to discuss, explain in detail anymore. So we will get this as the, okay, we can write like this, n minus 1 ln n, expand the 1 over n into both, then you get this. Okay. So now, that done, this is your ln. This is your ln. Okay. So therefore, your ln look like this. Now, perhaps the second part of the second terms, perhaps this part we can make it like this. We can make it become minus the 1 minus 1 over n ln n. Okay, now, so this is your ln. And now we're moving on to the part B. Part B, they want you to simplify un minus ln. Un, just now, the result un was the result was 2n factorial over n factorial minus the ln n. Your Ln formula is 1 over n of ln 2n minus 1 factorial over n factorial minus a 1 minus 1 over n ln n. Okay, so we are focusing on yellow minus the yellow and the blue minus the blue. So we're focusing on them separately. So for the yellow color part, it will be ln minus ln. So it will be 2n factorial over n factorial multiply n factorial over the 2n minus 1 factorial. And the blue color part, it will be actually, it will be minus this one, it will be minus the ln n plus the ln n minus the 1 over n ln n. Okay, so this one cancel. This one cancel. Then you get 1 over n ln 1 over n ln 2n minus a 1 over n ln n. Factorize the 1 over n out, you get ln 2n over n. At the end, you get ln 2 over n. Okay, so this will be your un minus ln. Then after that, we consider the limit of n go to infinity of the un minus ln. That will be the same as the limit of n go to infinity of the ln 2 divided by n. That will be a 0 shown. Okay, so this will be the answer for the C. And then moving on, we have question number 6. Variable x and y are related by the differential equations like this. It is given that when x equal to 0, y equal to negative 3, and dy dx equal to 2. We want to find y in terms of x. That means we need to find the particular solutions. So we start from the auxiliary equations. So we just get the AE. We get 4m squared minus 1 equal to 0. You get m equal to plus minus half. So your complementary solutions will be yc equal to the AE power half x plus the BE power negative half x. So we go for the particular integrals. This is a constant, so your particular integrals, we can call this as the B. Then I get the yp prime is a 0, and the yp double prime is also 0. So we replace it inside. You get 4yp double prime minus a yp equal to 3. That will give you 0 minus the b is equal to 3. The b is a negative 3. So you found the yp is a negative 3. Your general solution is yc plus yp. That will be ae power half x plus the be power negative half x minus a 3. So we found the general solutions. Now we want to go for the particular solutions. We need to find the dy dx. dy dx will be half ae power half x minus a half be power negative half x. So given when x is equals to 0, your y is a negative 3. Given this result. So based on this, replace it inside here, you will get negative 3 is equal to the a plus b minus 3. Your a plus b is a 0. That will be your equation 1. X is a 0, dy dx is 2. dy dx is 2. So you will replace it inside these equations. So you get 2 is equal to the half a minus the half b. Half a minus half b. That means your a minus b is a 4. That will be your second equations. Take the 1 plus 2, you get 2a is equal to 4. Your a is a 2. From the equation 1, your b is a negative 2. So we have found the a and b. So therefore, your particular solution, your y is equal to the 2e power half x minus the 2e power negative half x minus 3. Done for the part A. Done for the part A. Now we are going for part B. Part B, they want you to find the exact value for x, which the y equal to 0, and they want you to give the answer in logarithmic form. So for part B, we just need to let the y equal to 0. So 0 is equal to the 2e power half x minus the 2e power negative half x minus 3. So you will get e power half x minus the e power negative half x is equal to the 3 over 2. We divide 2 here, make it become divide 4. So the reason I do this is because I want to make this become hyperbolic function. This will be sine half x is equal to 3 over 4. So my x is actually equal to the 2 arcsine of 3 over 4. So use the formula, check the formula booklet, the logarithmic functions of hyperbolic arcsine, hyperbolic inverse hyperbolic function arcsine. So it will be 3 over 4 plus the square root of 9 over 16 plus 1. So you get 2 ln 2. That will be the answer. Okay, so this will be the answer for the part B. Done. Now we are moving to the number 8. Find the integrations of sine theta multiplied by cos power n theta d theta. So over here for these questions, we will be using this formula. F prime fx to the power of n dx. Your result will be fx power of n plus 1 over the n plus 1 plus c. Okay, so over here, our f theta will be cos theta. Your f prime theta will be negative sine theta. Okay, so we'll be using this, but we need to modify it because it doesn't fulfill the form at the moment. So sine theta cos power n theta d theta is actually negative sine theta cos theta power n. So by arranging them in this way, so that now it's fulfill this form, we can integrate them directly. So if we integrate them directly, you will be getting negative of cos n plus 1 theta over the n plus 1 plus c. Done. That will be the answer for the number 8a. Okay, so now we move on. B. Let the IMN look like this. And they want you to show that for m greater than or equal to 2 and n greater or equal to 0, then this relationship is true. So for this question, you can see that the m is represent the power of sine, n is represent the power of n. So you can see that they want to show that this equal to this. The m is minus 2. So the one way for this power to be decreased is you have to differentiate them, then the power can only be decreased. So this question we shall use integration by part to solve it. So the trick is like this. Integrate 0 to pi over 2 sine m minus 1 theta sine theta cos n theta d theta. So first of all, we borrow sine theta out from the sine power m. So this one we want to integrate. This one we want to integrate. Okay, that means this one we want to differentiate. So by apply the integration by part rules, then you will get that this one remain. This one you integrate. You integrate this one, how to integrate? You actually just refer from the answer in part A. Answer in part A, we have this result already. We just apply this result directly will do. Okay, so we just apply this result. Then you will get this one as the negative cos n plus 1 theta over the n plus 1 from 0 to pi over 2 minus the 0 pi over 2. Now we want to differentiate this. So this one it will be m minus 1 sine m minus 2 theta cos theta, provided we have integrations over here. This one we copy down. So we will be having not enough space. My apologies on that. Okay. So maybe I write it down here. It will be minus the 0 to pi over 2 m minus 1. The power here has decreased to become power 2 using the chain rule. Then this one it will be negative cos n plus 1 theta over the n plus 1 d theta. So the negative and the negative here, we will combine them together, become positive. And the constant here and the constant here, we will pull it out. But first of all, we need to set this part. This part, if you replace pi over 2 inside, cos pi over 2 is a 0. And then if you replace 0 inside, sine 0 is a 0. So over here for this part, the whole thing is actually a 0. Okay, so it's actually a 0. This part, the whole thing is a 0. Then the negative and the negative has been combined together, become positive. So this one will become plus, integrate 0 to we factorize the constant out. Make this become m minus 1 over the n plus 1. Integrate 0 to pi over 2. So we have a sine power m minus 2 theta. And we get the cos n plus 2 theta d theta. We have something like that. So we can see that over here we will make use of the power of cos. We borrow the cos square out. Just go right down here. The sine power m minus 2 is considered done. Now we make the cos square out. Make it become cos square theta multiplied by cos power n theta. So this part, we split them become this. Okay, we split them become this. Then the cos square is actually 1 minus sine square. Cos square is 1 minus sine square. So this one will become 1 minus the sine square theta cos theta, cos power n theta d theta. So if we continue to expand them, so you will see that it will become sine power n minus 2 theta cos power n theta minus the sine power m theta cos power n theta d theta. So this is the trick. we split them in such a way. So if we split them in such a way, then we can write this one as a I m n is equals to this. Is a I m minus 2 n minus this. So if we combine these together, you will get 1 plus the m minus 1 n plus 1 I m n is equals to the m minus 1 n plus 1 I m minus 2 n. Simplify it. You can see that you will have a m plus n over the n plus 1 I m n equal to the m minus 1 over n plus 1 and I m minus 2 n. Done. Almost. Okay. So therefore, your I m n is equal to this one cancel. M minus 1 m plus n multiplied by this. Shown. Okay. So this is the answer for the part B. Now we move on to the part C. Part C, we are having binomial expansions over here, where the z is cos theta plus I sin theta. So first of all, we start from z equal to the cos theta plus I sin theta. So we make the 1 over z become z power negative 1. Then you get cos theta minus the I sin theta. So the z plus 1 over z. Okay, I think maybe because we actually can foresee these kind of questions actually quite routine in the past year exam questions. So we know that we actually need to do z power n. By applying the Moivre theorem, we will get this. Then similarly, z power 1 over n will give us cos n theta minus I sin n theta. So we have a z plus 1 over z is equal to the 2 cos theta. And we are having z power n plus 1 over z power n is equal to the 2 cos n theta. Okay, so we get this these two formula ready first. We get these two formula ready first before we solve the problem. So we start from here. Z plus 1 over z power 5 is equal to the 2 cos theta power 5. So I write the 2 cos theta power 5 at the left hand side. I get 32 cos power 5 theta. Then the right hand side, I do the binomial expansion. I get z power 5 plus 5z power 4 multiply 1 over z plus the 10z cubed 1 over z squared plus the 10z plus the 1 over z cubed and plus the 5 minus space. I write over here plus the 5z. This one is a square. This one is a z. And then 1 over z power 4 plus the 1 over z power 5. Expand simplify, you will get z power 5 plus the 1 over z power 5 is one group. Then the z power 3 plus 1 over z power 3 is a one group. And z plus 1 over z is another group. Okay. So by applying this result, the result over here, then you will get this one as a 2 cos 5 theta plus the 10 cos 3 theta plus the 20 cos theta. Okay. So we are looking for cos power 5. So cos power 5 theta is equal to the 2 divided 32, 1 over 16. This one is a 5 over 16. This one is a 5 over 8. Okay, done. That is the answer for the part C. We have found the ABC. This is the A, this is the B, and this is the C. Okay, so now we move on to the part D. Using the result given in the part B and C, find the exact value of I to 5. So, to find the I to 5, that means the M is a 2, the N is a 5. Okay? So we just need to let our, using this formula, we just copy the result just now. The part B result is like this. Okay, so we copy this result here. So M is a 2, N is a 5. So you will get I to 5 is equals to the 2 minus 1, and then 2 plus 5. Then it says I05. So it will be 1 over 7. I05 is integrate 0 to pi over 2 sine power of 0 theta cos power of 5 theta. But we don't need to waste our time writing the sine power 0 because we know sine power 0 is a 1. That means this is the same as a cos power 5 theta d theta. Using the result in C, we know that the result in C is a 1 over 16 cos 5 theta, 5 over 16 cos 3 theta, plus 5 over 8 cos theta d theta. So we just integrate them one by one. This will be 1 over 80 sine 5 theta. This will be 5 over 48. 5 over 48 sine 3 theta. Plus the 5 over 8 sine theta. The value is from 0 to pi over 2. So when you put pi over 2 inside, you get 1 over 80 multiply 1. This one you will get 5 over 48 multiply negative 1. This one you will get 5 over 8 multiply 1 minus all the 0 behind. And the rest, just need to use a calculator. Just get a help from calculator. Press the calculator, then your answer will be 8 over 105. Done. This will be the answer for the question number 8. And this will be the last question for this paper. So I stop the video here. I'll see you then. Bye-bye.